So what if an AI didn't just learn from the data we give it, but could actually, well, dream up its own experiences to understand our world? It sounds like science fiction, right? But that's the incredible idea behind what's called physical AI. And today, we're going to take a look at NVIDIA's brand new platform designed to make it a reality, Cosmos.
All right, here's a quick roadmap for our explainer today. We'll kick things off with the core problem this is all trying to solve. Then we'll introduce this new concept of physical AI. After that, we'll dive right into the tools inside the Cosmos platform, see how it's already having an impact in the real world, and then finally, we'll look at what's just around the corner.
Okay, let's just dive right in. You see, to really get why Cosmos is such a big deal, we first have to understand the massive challenge it's been built to solve.
I mean, just think about it for a second. How in the world do you prepare a self-driving car for, I don't know, a deer jumping out at dusk, or a sudden crazy hailstorm, or a kid chasing a ball into the street? You can't just drive around hoping to record every single one of these rare, once-in-a-lifetime events. It's impossible. And that right there, that gets to the heart of the problem. The real world is just infinitely complex. Trying to rely only on collecting real-world data is, frankly, a losing battle. It's super expensive, it takes forever, and you will never capture all the weird edge cases. This lack of data has been the single biggest roadblock to creating truly intelligent machines.
So, how do we get around this seemingly impossible data problem? Well, this brings us to a really groundbreaking new concept, physical AI. And trust me, it's a total shift in how we think about teaching machines.
Physical AI is really the end goal here. What we want is to build intelligent agents, robots, autonomous cars, whatever, that can operate safely and effectively in our chaotic, unpredictable world. They need to understand things like physics and context and cause and effect, not just recognize patterns in a bunch of pixels.
And this leads us to a really elegant solution. If we can't collect all the data we need, why don't we just create it? This is where World Foundation Models, or WFMs, come in. They are the engines that power physical AI. They use these powerful generative AI techniques, kind of like what creates AI art, and they act like a dream engine, generating endless streams of realistic, synthetic data that an AI can learn from inside a simulation.
So, how does NVIDIA actually go about building these dream engines? Well, they've created a whole platform specifically for developing these World Foundation models, and it's called Cosmos. So let's crack open the toolbox and see what's inside.
Cosmos is basically built around 3 core engines, and each one has a very specific job. You can think of them as specialized tools for building these AI dreams. One is like a crystal ball, one is like a weather machine, and one is like a detective.
First up, we've got Cosmos Predict. This is the AI's crystal ball. It can take all sorts of inputs. You can give it text, images, or even other video clips, and it will generate up to 30 seconds of realistic video showing what it thinks might happen next. This is absolutely perfect for simulating future scenarios to train an AI on all the possible outcomes. Next, there's Cosmos Transfer, which, I love this analogy, is like a weather machine for your data. You can take a single video clip, let's say a car driving on a sunny day, and Transfer can instantly change it to a rainy night, or a foggy morning, or a dusky evening. It basically multiplies the value of every single piece of data you have. And finally, there's Cosmos Reason, which is the visual detective. It's a really powerful vision language model, or VLM. And what that means is it's an AI that connects what it sees in a video with language. So it can actually understand what's happening, it can answer questions about it, and it can even make judgments about a scene. Okay, so the theory is fascinating, and the tools are obviously really powerful. But what does this actually mean for us? Let's take a look at how Cosmos is already being used to solve real-world problems. Right now, the impact of this technology is really being felt across 3 huge arenas. We're talking about creating smarter robots, building much safer autonomous vehicles, and enabling more responsive and intelligent video analysis. For robotics, this is an absolute game changer. Imagine a robot learning to sort packages in a huge warehouse. Instead of just training it on a few different box shapes, you can use Cosmos to generate millions of virtual examples. Different sizes, different weights, different textures, even boxes that are all beat up and damaged. The robot can learn and fail countless times in this virtual world, so when it sees a real crumpled package, it knows exactly what to do. Now, for self-driving cars, safety is everything. It's paramount. With Cosmos, developers don't have to wait for a dangerous situation to happen in the real world to learn from it. They can just create it. They can simulate black ice, or a pedestrian suddenly stepping out from behind a bus, or blinding sun glare at 1,000 different intersections. all without putting a single real car on the road. This makes the training process just exponentially safer and way more thorough.
And this technology isn't just for things that move. Think about smart cities. An AI trained on Cosmos data could analyze traffic camera feeds to instantly spot an accident, automatically alert emergency services, and reroute traffic to prevent a massive pileup. Or, in a factory, it could monitor machinery for tiny vibrations that signal a failure is coming, preventing costly shutdowns before they even happen.
Okay, let's wrap this all up by pulling back and looking at the bigger picture and what the future holds for this incredible technology.
And this might be the most important part. NVIDIA isn't keeping these tools locked away in a vault. The Cosmos models are openly available on platforms anybody can use, like Hugging Face and GitHub. They're designed to plug into other powerful tools like Omniverse, and they're optimized for the latest hardware. This creates a powerful, accessible ecosystem for developers everywhere to jump in and start innovating.
And this quote from NVIDIA really just sums it all up perfectly. You've got Omniverse, which is the platform for creating these physically accurate 3D worlds. You can think of that as the stage. And then Cosmos provides the foundational models to generate endless video data inside those worlds. It's like the Dream Writer, filling that stage with infinite stories for the AI to learn from.
So, this leaves us with one final, fascinating question to think about. We are literally building machines that don't just process data, but can generate their own virtual experiences to learn from. If an AI can dream to understand our world, what are the limits to what it will eventually learn to do within it?